Please hang up and try again.
Today we talk about the introduction to linked lists. It starts with a definition of node. Remember that a linked list, in previous conversations that we have, we want to have a structure that basically holds a data value and a reference to the .next. So basically the node is, believe it or not, another data structure. It's a small data structure that only will be used in linked lists. Remember that we want to store values in memory. If you don't remember, basically we would like to store information in memory in a non-contiguous way. Remember that in arrays we store everything contiguous. In a linked list we basically do it everything in a dynamic storage. So the node that we're going to have today, we're going to start to discuss the class node, is going to be used only in linked lists. Basically will be a storage where we're going to store the information. It can be an int, it can be a string, it can be any kind of object. You can visualize the node as this box that I'm pointing right now. So basically the box will be storing information, as I said, a primitive types or string or whatever you want to store. And this blue small box, it will be the reference to another node. Yeah, we're gonna call this value .next, and the information that we're gonna store here is gonna be the called value. So we're gonna start with the definition of the class node. As I said, we're gonna hold a value and we're gonna hold a next. Now for now we're gonna store just strings as the value we like to store there, and the next, and this is where the fun starts here, the data type where the next is gonna hold is gonna be a node. The node, why node? Because if you visualize this box, the box will contain a reference to memory that is going to point to another box. So basically we're going to connect a lot of boxes, like what we're trying to do here. A box connects to another box. I'm going to zoom in this real quick. A box will point to another box. That box will point to another box. Box. Yeah, those are called the nodes. They're connected through this .next, is the arrow that you can see here. That will be the .next. The .value will be the information that we're going to store inside. That's why the .next has to be data type of node, because a node connects to another node. That's how it is going to be. So let's go back to the code. So it doesn't hurt to have constructors. So basically we're going to have public node. Yeah, it can be, we have a couple of constructors. Let's start with the very basic one where we have a string for the value. So basically this value, the one that we have on line 2, will contain the value that we're passing on the parameter. Because of the purpose of the whole constructors is to initialize all the fields, we also need to initialize the .next. That will take place by, usually we have another parameter, but here we don't. So we're going to provide the value of null. If you remember, null will be the default value for any object that we have. We'll provide another constructor called public node, the one that provides the string value, the one that provides a node next. This makes more sense. If you want to have this value, will contain the value that we pass as the parameter, and this .next will hold the value of the next that we pass as a parameter. This is ideally we provide both parameters in the constructor. Okay, that's it. That's basically the only reference that we need to have. This is our structure for the node. And as I said, since we're going to discuss this node only, we're going to create another class called public class node tester. So node tester will basically be, let me just save this real quick. Let me just, in case you don't see it. Actually, I don't see it in the desktop. Did I save it? Let me see, did I save it correctly? Oh yes, here it is. I was zooming in a little bit more. So here we're gonna test the actual node that we have in the same directory. So let's see, I think I have this example right here. In the main, I'm just gonna copy this and paste just for the convenience. You can do this at home if you want to. If not, don't worry, this is in the website. So I'm gonna create a couple nodes here. I'm gonna create 5 nodes. As you can see, node 1, node 2, 3, 4, 5. I'm using the very first constructor that I create here. Yeah, the one that has only one value. We're gonna initialize that. Notice that the .next, it will be the null. Yeah, because we're just providing one value as a parameter. Here it's the parameter that we pass in A, B, C, D, E, and E. We're creating 5 nodes. I'm gonna save this directly. So notice that we want to accomplish this connection. B connects to A connects to C, C connects to E, E connects to D, D connects to something else. These 3 lines as you can see, these 3 lines represents the null. Yeah, that if you can read this in many books, in many websites, in Wikipedia, I don't know. The 3 lines like that represents the null. So when we have that, we need to establish the connections. So B, A, C, D, E, and F. So I'm just gonna put this as a reference. B, A, C, and then E, and then D. We want to connect them. Now, B, the value of B, is being held by N2. So basically, we're gonna establish the connection here. N2.next is gonna get the value of who's containing the value A, N1. So basically here, oops, yeah, here we're gonna establish the connections. So B2.next will be pointing to N1. N1.next, it will be pointing to, if we want to connect it to the node containing the value C, will be who? N3. So now N3.next will be pointing to, we want to know who contains the value E, which is N5. N5.next will be pointing to who contains the value D, N4. Yeah, and N4, should I put N4.next will be who? So notice that N2, which is B, is connected to A, which is N1. A is connecting to N3, which is C. And then N3.next will be E. N5.next will be D. Yeah. So if we want to have D connected to this value, you can put here null if you want. Yeah, but it's a little bit redundant because why? If we go, notice that when we create those 5 nodes here, we're using the very first constructor. So the very first constructor, we provide a string, which is right here, and the .next is already initialized to null. So we don't really have to provide an extra value of null because it's already been there. So let's see. Good, seems to be fine. So if we try to system out parent line, who contains the very first value? The node containing B will be N2. So if I print N2 like this, let's try this. I just need to change to the desktop, and then I'm gonna do Java C, Java compiler. Just a friendly reminder, Java C will give you the compiler. I know I'm not using Dr. Java or IntelliJ or NetBeans. I'm using the Visual Studio Code. Yeah, so I have to compile it directly through the terminal. So Java C node tester, it will compile and it will generate those class files that I'm just going to put it here, right here. Yeah. Now, if I try to run Java node tester, your question is, when I try to print line 15, you might think that you're going to print the entire list like that. But instead of that, we get this, boom. We get this funky hexadecimal address location, which basically specifies that it will print the node that is located at this hexadecimal address location, right? So God knows what this is. So basically that kind of broke our heart because we were expecting something more like BACD, or something else. Yeah, but instead we get the hexadecimal address location, which is kind of a pain, but it makes more sense because if we want to print N2 is a node, that is an object that is located in an hexadecimal address location. And if we want to print the value that is inside there, we just have to put N2 that value. If I compile this again, run it, I got B, which is indeed what we want to have at the very beginning. How are we going to print A? And I know what you're thinking. Oh, it's very easy, Professor. Check this out. The only thing we have to do is what? N2 dot next, like that. Notice that this will give us what? You might think that will give us the A, but again, let me just break your heart again. It will give you the hexadecimal address location. Notice that this will be a different hexadecimal address location from the B, because N2.next points to the next node that is connected through the .next of N2. I know is A because here we established that. But if you want to extract the A, you need to extract the dot value of that. So if that's the case, I just compile again. Ta-da. Okay? And I know what you're thinking. I want to print the next one. So you're gonna hate me a little bit more. So it will be n2.next.value, and that will print, no surprise there. What's gonna print here? The C. And of course, what the heck? I'm gonna do it all of them, right? So this will print the, what is this? The B. This will print the A. This will print the C. Yeah, this will print the what? The E. But here we just need to go one more next. Oh man, this is gonna mess up with my OCD. Let's just, all right, fine. There. Okay, and finally, we're gonna do the n2.next.next.next.value. Okay. All right, if I compile this, the last Java C, there you go. Yeah, so we're printing the whole chain by moving, by iterating one by one by using the .next, the .next.next, the .next.next.next, the .next.next.next.next value. That value allows us to extract the value from the node, Notice that this guy highlights the value that we're extracting. The .next will highlight the connection to the next node that is connected. Now, I'm just going to experiment a little bit more. What happens if I do n2.next, .next, 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 .value? What do you think is going to happen at this point? Usually, if you're in my class, you answer my questions right away, but this is not what you think is going to happen. Yeah, you might think, oh yeah, I saw those 3 lines there, professor, which is the null. Yeah, and you might expect to have the null. And you're not that wrong, to be honest, but if I try to do this again, Java C, Java node tester, check this out. Boom. We crash the entire program. So we got a null pointer exception. A null is different from a null pointer exception. And the reason is because null, remember, is the default value for any object that you can have in Java. It can be a string, it can be a cow, it can be a dollar, it can be whatever you want. Yeah. Not necessarily a node. Yes. By using those constructors, the second constructor or the first constructor of node, the .next will be initialized to null, but doesn't mean that you're gonna get the null, because the .next is already the null. If you want to see the null, you just have to remove the .value. There, yeah. So this whole line, it will give you the null. But if you try to extract the value from that guy, you don't have a string. The null doesn't really have a string. It doesn't have a value. The null is the null for every default value. That's why here Java is complaining with you. You're trying to get a null pointer exception because you're trying to access something from the null that doesn't really have. Null is the default value for all objects. This is a typical mistake. And this is a typical mistake that you're going to have for the rest of your life if you don't have control of who is controlling to the null. Node is only one of the very first objects that we're going to discuss that deals with null. But eventually you're going to talk about more and more objects that deals with the null value. So this is something that you need to be careful about this. We're going to continue discussing this more in detail in the next